We would like equation of the plane that contains these parallel lines. If we put the value of the parameter t here equal to 0, we see that the line passes through the point 1, 1, 2, and with the same reasoning, the blue line passes through the point 2, 3, negative 1. And the coefficients of the parameters show that both of these lines are parallel to 2, 1, negative 1, the vector with those components. Now if we connect these 2 points, we will get a vector, okay, and the vector will, or rather vector can be written as, we can use the coordinates of this point or these 2 points, this as the initial and this as the terminal, by taking 2 minus 1, that is 1, 3 minus 1, that is 2, and negative 1 minus 2, that is negative 3. So this vector with the components 1, 2, negative 3 is contained in the plane that contains the 2 lines. And we have another plane that is another vector that's contained in that plane, and the 2 are non-collinear. So if we take their cross product, that is the cross product of this vector with this, then we shall find components of a vector perpendicular to this plane. So now we have a vector perpendicular to the given plane, and we can choose a point on the plane from either of these 2 lines. Let's choose this one. So we find that the plane passes through 1, 1, 2 and is perpendicular to the vector with these coordinates, with these components. So let's calculate this cross product to get the components of the perpendicular vector. So we'll go ahead and get our determinant, that is, here you have negative 3 and then minus 2 times negative 1, that will give us negative 1 times I. And then for j, what we do is this, that we are going to ignore these 2, okay? And that will be negative j, and that's going to be negative 6 plus 1, that is negative 5. So we get here actually negative 5, with that negative j will become positive j. And then we have 2 times 2 is 4 minus 1, that is simply 3k. Oh, now here I have a typo. This should have been 5j. I said 5j. I don't know why I wrote just j. And this should be what? This should be a 1, right? So all I have to do now is write equation of a plane that, or rather the plane that passes through 1, 1, 2 and is perpendicular to the vector negative 1, 5, 3, and that plane will have equation. We have negative 1 then times x minus 1, because the component here, sorry, the first x coordinate here is 1, and then plus 5 times we got y minus 1, right? And then plus 3 times we have z minus 2, and that is equal to 0. So if we go back to our slate and plot the plane, we can see that we have this plane, we obtained the plane that contains these 2 lines, all right?